law of inertia, also known as Newton's first law of motion, states that an object rest will remain at rest, and an object in motion will remain in motion with a constant velocity unless acted upon by external force. When we pull the car using a yarn, it is essentially at rest, and according to the law of inertia, it will remain at rest until an external force acts upon it. When the toy car makes contact with yarn, the force of pulling acts as an external force, causing the toy car to move. The law of acceleration, also known as Newton's second law of motion, states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. When we push an empty chair, it moves easily because there is no significant force resisting its motion, and the chair has a small mass. As a result, the force we apply to the chair is greater than the force resisting its motion, and the chair accelerates easily. However, when someone sits in the chair, the mass of a chair and the person increase significantly. According to the law of acceleration, the greater the mass of an object, the greater the force required to accelerate it. Therefore, when we push the chair with someone sitting in it, we need to apply a greater force to overcome the increased mass and accelerate the chair. The law of interaction, also known as the Newton's third law of motion, states that for every action, there is an equal and opposite reaction. This means that when we are walking, our feet push against the ground with a certain force, and in return, the ground pushes back with an equal and opposite force, propelling us forward. Without this law of interaction, we would not be able to move forward while walking.